Last session is dedicated to cybersecurity, IoT, and 5G challenges, stakes, and potential solutions. My name is Adam Kapovits, and without further ado, let me introduce the speakers. I think I managed to put them in the right order now. So first, Dr. Ko will talk about the 5G research in 6G research in Korea. Then Professor Aguiar will present both 5G and cybersecurity issues. And then we have Professor Lee, who will present the 5G and research in Korea. Professor Kim follows from Sejong University, and then Sung Myung Jung from KETI will present specific aspects of IoT. I'm very happy that we have so many Korean presenters, and with that, I would like to just hand over to Dr. Ko.
Thank you, Adam. Thank you. My name is Namseok Ko from SERI. I'm the director of Mobile Core Network Research section in SERI. So, okay. So actually, I prepared lots of slides in the beginning to explain all the details about the area that I'm working on. But considering the time that we have today, I removed all the details, and I'll make you happy on this one. So I'll briefly introduce the current 6G R&D status in Korea. So if you have any questions on this one, then if you send an email, then I'll kindly respond to that. So 6G framework was defined in IoT. So the usage scenarios were defined. So based on 4 overarching aspects and design principles for scenarios like sustainability, connecting the unconnected, ubiquitous intelligence, security, privacy, and resilience. So based on this overarching aspect, the 5G usage scenarios were extended, like EMBB were extended to immersive communication, URLC is to HRLC, and MTC is to massive communication. And then new usage scenarios were defined, is ubiquitous connectivity and integrated AI and communication, and integrated sensing and communication. So I wouldn't explain all the details of these usage scenarios, but based on these usage scenarios and also the capabilities defined in IoT, but for now, the numbers are not yet defined exactly. The numbers will be defined later at technical performance requirement phase, which is planned 26 February. So here's the current 6G R&D status in Korea. So we have these strategic areas. First one is advanced wireless technologies and software-centric network evolution technologies, and technologies beyond communication, energy-saving technologies, and technologies for supply chain enhancement. So based on this strategic area that we set up, we selected 11 projects on these 3 areas, like RAN, mobile core network, and wired network and system. And a little bit of details will be explained in the later slides. So for the 6G spectrum, we are approaching to a layered approach. So we are considering multiple spectrums, like from low band to high band, like sub-terahertz. But each different frequencies are for different applications. So for sub-terahertz, it is for sensing and ultra capacity, and low band this is also for extended coverage. So Korea actually proposed two candidate mid-band frequencies, and both of them were adopted. To support upper mid-band spectrum, we are working on extreme massive MIMO systems and also the related components. So we are working on this eMIMO and eMIMO base station components. And for radio access network and core network, cloud native approach and AI native approaches are being pursued. So, and also, basically, mobile core network is already cloud native, but in radio access network is also being, moving toward cloud native systems. So even, I guess you are familiar, I guess many of you already heard about Open RAN and also AI RAN these days. So RAN also is moving toward cloud native. And every place AI is being adopted. Even 5G, we already discussed AI, but it is being more natively supported. So based on this AI semiconductor and AI technologies, we are moving toward AI native RAN and also mobile core network. Especially in radio access network using the AI technologies, we are trying to achieve energy efficiency. So in max scheduling and also in other parts of the radio access network, AI is already being discussed. And wired network as well, we try to support ultra high speed and capacity, or optical transmission system, and also the related component technologies are being developed. In the system area, to support, to ensure end-to-end performance assurance for diverse 6G services, we are working on the framework for end-to-end service performance assurance and also service orchestration for AI native services. And finally, this is the final slide. It is very simple, right? So we started our project from this year, April this year, and it will run until for 5 years. So after 2 years, at the end of 2026, we are going to demonstrate 360 systems based on the project research that we are working on. So we'll showcase the 47 core technologies in 11 strategic technology areas. So I guess many of you will be also invited to the Pre-60 Vision Fest event at the end of this 2026. So this is it. Thank you very much, and arigato gozaimasu. And I didn't practice this one, so thank you very much.
Thank you very much, Dr. Ko. Unfortunately, I think Dr. Ko's agenda doesn't permit him to stay with us until the end of the session. So if you need to leave, then. Yeah.
Also, if you have any questions on this slide, and also because as I said, I'm the director of the Mobile Core Network Research section in SERI. So actually, the slides that I originally prepared are mobile core network related technologies, but I didn't show anything about that. So later, if you're interested in mobile core network in 6G, then please ask any questions on that. Thank you very much.
Thank you, Dr. Ko. I would like to hand over to Professor Aguiar.
So, can I walk? I can walk here easily. Okay, so good afternoon. I have here a couple of slides for where I'm coming from, but since we have not much time, I'm the steering board chair of something called Network Europe, about 1,000 organizations. One of the things that we do is that we write a strategic research and innovation agenda for communications in Europe. I am also a member of a research institute, a national research institute. I'm the director of networks and services. And then I have my own research group where we do work a lot on communications, especially control and management plane. So see, less than 1 minute for saying where I'm coming from. Right. So what I'm here from this audience, I think that the whole point is that we should start by this. We are coming on this digital society. We see here some of the sessions that we had today, smart and secure cities. People talked about digital services. We'll talk a lot about sustainable mobility. So this is where we are. Everything that we are talking and discussing here is actually talking about the digital transition. That's the point. Now, this assumes that it's more advanced society, more intelligent environment, it's better for the citizen, better for the environment, society, blah, 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 blah. Okay, we can go on. You all know about this. You also know, like, for instance, my daughter, which is 31, considers myself a digital analphabet because I am not on the social media. And in fact, I never understood the TikTok, okay? So the world is changing. We know that. And conveniently, we are sweeping under the rug all the problems that we don't know how to address. Okay, and those problems are a huge amount of things, but it's like Silicon Valley, right? Move fast and break things, and then we see what happens. So, in fact, is the security aspect the problem that came here recurring at this several times? Do you really believe that a system more complex is more secure? Because if there is here a secure expert and he tells me he believes that, I will ask where he read that. Okay? We all know that the more complex the system, the harder it will be to make it secure. And we are talking now about the society. We are bringing a huge amount of technologies together. And the security of any system is as secure as the weakest link, right? So, just to make sure, this picture disappeared, all right? Just make sure to grab some of the things that were here spoken. IoT, AI, and 5G. In fact, the 5G and transition to 6G is the enabler of all this. The fact that we are, I'm looking around, lots of people walking on the laptops, lots of people looking at your cell phones. Ladies and gentlemen, you assume that you can do that. What the heck? When I was the age of you, this was, miracle. Absolutely miracle. I am a dinosaur because I don't change as fast as the society. The society doesn't as fast as the technology. Sorry about this, okay? We engineers, and sorry, let me put my engineer hat, are much faster in developing technology that you are not able to use. Simply because I still use something called VI, for those of you that have the age to know what this is. And certainly, although my daughter now considers me a dinosaur, 10 years from now, she will be the dinosaur. So this is the kind of things that we have. And we talk about AI, IoT, 5G. Look, at this moment, lots of people talked about IoT in specialized domains, right? Come on. The whole value will be when everything is interconnected. That's what we are promising on 6G. And when we talk about things like, smart cities, the whole point is bring everything together. Put all the data and then mine all the data. And for mining all the data, you need, of course, the AI that at this moment is being used in specialized domains. And I've heard here a huge amount of persons saying that we need to use this in specialized domains because each one is really specific. But again, the value is in bringing everything together. And of course, who brings everything together is 5G and 6G. Frankly, there will be no other network than 6G. Forget the difference between fixed networks, local area networks, cellular networks. The ambition is one network to rule them all. I don't know where I got this sentence for one. It's one ring to rule them all. Sometimes I have, some other things. So this is what 5G research was. I'm not going to talk about it. I saw there were lots of things about what 6G is. For those of you that are not known, the 6G research, the 6G standardization process is starting next year. So I try to avoid saying what it will be because it's starting. Until now, it's simply a wave that we use in terms of getting funding, of course, and of course in trying to influence what will be the future. But we are near the process when it's going to become a reality, okay? So I will avoid that. So whatever it will be, the 5 or 6G, it will be the network for everything in our society, okay? This includes from the physical to whatever level that you imagine with the amount of different multi-stakeholders that you imagine. Everything will go through this infrastructure that will reuse everything available. And then we have here the small problem of security, right? Now, in Europe, I don't need to tell you that, and I have heard from this audience that you already know that, we do have clear security mandates inside the EU. And being me an engineer, and I'm seeing here a very interesting speaker a couple of minutes ago, I mean, this is clear in the sense that there is a basic framework, right? Now, I am an engineer, which means I smile a lot on what that framework is able to do for somebody that actually, as I said in a question a couple of minutes ago, when I do things, they are done. And then you can have your opinions, but that's what, it's running code that will matter, right? So this is a problem. More than that, the whole process is inconsistent. You can have two neighboring nations taking decisions completely different in terms of cybersecurity. And of course, in Europe, we cooperate, which means that whatever kind of decision that one nation takes, it's, in some cases, something like a wishful thinking. And now we have these problems on supply chain challenges. Notice the problems of supply chain, part of it, it's on future intention judgment. So it's extremely security-oriented. And by security, I mean, military security-oriented. Now, we have the geopolitical considerations. And for those Europeans, we just need to look at our different countries and see that the politicians don't necessarily always think the same. We know what may happen in Germany or in France in a couple of months or in 1 or 2 years, and then suddenly these geopolitical considerations may change. Again, things that I design, then it's running code. It doesn't really matter if politicians change, unless you want to pay for revamping everything that is already running, okay? Now, we, in terms of technical security, are having a huge amount of problem with this, right? There are ways to address this. As diversity of chains, which may be slightly extra cost, but the whole point is that it will be very nice if we stop making security a process-dominated stuff. I know that for the human in the loop has to be there, but it's extremely complicated because we cannot guarantee the performance. And in fact, we want to have technical ways of addressing this. And this is actually part of the research we are doing for 6G. We need to have, I said that, clear and auditable regulations, but this means technically auditable, not on the opinion or a personal assessment, which is always questionable. And this should be across the whole technology chain. We already have some things for this in cloud. We don't know how to do it in AI. The security establishment for telecom exists, but at this moment is very much a matter of process as well. Then what we need to do is to actually define things like risk-based approaches. We need to find what this human in the loop means, which is actually a problem. It's very unclear, and we heard the discussion a couple of hours ago. And then we need models for what's the cost and what's the risk that we're willing to pay. because at this moment, this is a absolutely human judgment without any care of support. Now, we need to develop those models. Those models don't exist. We need to develop things like how to quantify security. How much is enough of security? The old joke is that, of course, a secure computer is a computer inside a cellar which is not connected to the internet and has a safe bolt on the entrance. This is a secure computer. Of course, this is useless. So we need to figure out how we can quantify security. And look, this is system-level security. It's built by multiple parts. Finally, how do we do this in terms of technology design? We are starting the design of 6G. Can we do this in such a way that we cover 6G when it appears, sort of has this kind of concerns already incorporated? Again, this is part of the challenge that we have for 6G. And finally, of course, we need education and knowledge, both from the engineers, both from the population, and also for everybody that is involved in ICT technology, including understanding the trade-off between user experience, cost of security, and the technology required and the innovation required for bringing both of them in a matching level. And I think this is all I have here. Conclusions, but look, in conclusion, since this is an international forum, we are very good in regulation, but our regulations are guidelines. We need to figure out how we are going to move from regulation to technology. And at this moment, developing technology, we should see if we can blend two things, okay? So that's it. If you are not involved, join Network Europe. Thank you very much.
Thank you very much, Rui. I would like to invite our next speaker, Professor Lee.
Thank you, Adam, for a kind introduction. My name is Lee Hyun-woo of Dankook University in Korea, and also serving as the Vice Chairman of 6G Forum, Co-Global Collaboration, and also the Vice Chairman of a Mobile Standard Committee in Korea called TTA. Today, I will talk about regarding the 5G status and lessons and experience. Actually, yesterday's session, I made some speech on 6G. But today I'll focus on the 5G. 예, 다음. 예, 다음. Next. Yeah, this is the current statistics on 5G. So currently we have, the Korean population is about 52 million, and now we have 57 million mobile subscribers, slightly bigger than population. But this does not include the around 30 million devices like IoT, tablet, and wearable. So please keep in mind for these numbers. And among mobile subscribers, the currently 5G, we have 37 million that count for roughly more than 60% of the total mobile subscribers. So it means that the 5G is widely used in nationwide. Okay, next one, please. But the problem is that regarding the mobile traffic, this is mobile traffic 5G, and this is mobile traffic 4G. So at July this year, more than 85% of mobile traffic is handled by 5G. And around 29 gigabytes per month per user for 5G user. While for LTE, roughly around 7 gigabytes. So 5G consumes much traffic. But as you see in the slide, from deployment in early 19, the traffic increased rapidly, but after middle of last year, the traffic almost saturated. So what is the problem? So I will show it later. Next one, please. So regarding spectrum, the public spectrum is served by 3.7 gigahertz, while the private 5G in 4.7 and 28 gigahertz band. So different spectrum by public and private 5G. Okay, next one. In terms of coverage, population coverage more than 95%, and geographical coverage by more than 75%. But in Korea, the middle right side is usually the mountainous area. So we can say it almost completely covered by 5G network. And the average download rate is around 900 megabit per second. So very high data rate the 5G user can utilize. Okay, next one. Yeah, we started from non-standalone and now migrating to standalone gradually. But I think this is one lesson from 5G in Korea, but because we hurried up to deploy the network from as early as 2019. So at the time, we don't have a choice using NSA. But nowadays, the SA is the main train. So we changed the system. So I think that was some lessons. So we should not repeat that kind of experience in the 6G. So that is my view. And even though we have a nationwide coverage, next one, next way, please. Okay. For private 5G, we have separate frequency and separate small operator for private 5G. In many areas like transportation, manufacturing, medical, etc. So currently we have 31 organizations in 59 sites. They are using the private 5G. But compared with the public 5G, this is a small scale so far. Next one. Some missing, but it's okay. So summarized in 5G, the Korea was very, very fast to deploy the network. But as you could see in the mobile traffic side, that the mobile traffic is saturating. So I think I have three reasons for that. The first one is the lack of 5G specific devices. Like I think the Apple Vision Pro is very good device to increase the traffic, but as you know, so far there's too expensive and too heavy. But I think maybe next year some cheap version, a light version will appear from Apple and Samsung together. Then this kind of new device will accelerate the usage of the traffic. And second thing is the 5G specific service. For example, Metaverse was assumed to be good, nice service, but to provide the Metaverse smoothly, we should have both device and network and application together. But at this moment, there's not yet fully prepared. That's the second thing. And the third thing is that we, at first time, we assumed that the 5G will penetrate to the vertical industry very rapidly. But the application to vertical industry like transportation, manufacturing, is frankly speaking slower than our expectation. So I think so. That is the three reasons for slow the expansion of the 5G. So if the three reasons, three factors are solved smoothly, then that will be big motivation to migrate to 6G. Okay, this is my view. Thank you for attention. Thank you.
Thank you very much, Professor Lee. I would like to invite the next contributor, Professor Kim.
Hello, everyone. This is Jong-Young Kim from Sejong University. So, first of all, thank you for inviting me to speak at INPACE Symposium. I'm newcomers. Okay. So, today my presentation title is International Collaborative Research Project on Cybersecurity. So, actually, I'm going to introduce ongoing new project in Korea for collaboration with 3 countries, and USA, Korea, and Finland. So let me give you this overview of the project. The title is exactly Research and International Collaboration on Trust Model-Based International Instant Response Technology in 6G off-network environment. Actually, the duration of this research is 2.5 years, starting in July 2024. And the main object of this project is as follows. Mainly, we are developing the international intrusion detection technology, and then we are establishing international collaboration with 3 countries, specific USA, Korea, Finland. And next one is, it shows there is an annual research topic, and each year we conduct several activities with this 3 countries. And last one is a consortium. In Korea, we have 5 partners, and specific E3, and KISA, KAIST, Sejong University, and Kunmin University. And actually, the E3 is the leader of this project. For international partner, so we have US NIST and VTT of Finland and University of Finland. Please, next. I can handle that. Thank you. Okay. Next one, I would like to introduce our R&D technology and deliverables. Actually, we have 4 research areas. First is 6G trust model based on DLT and DPKI. Second is open security and resilience enhancement. Third one is distributed AI-based intrusion detection technology. Last one is detection and visualization of open network threat. We have limited time, so I'm not going to explain in details for each area. Okay, so for this area, we have research output expected, all of which are is software prototype product. And we have a technical report and technical design and patent and standard and kind of a dissemination activity and so on. And next one is I'm going to introduce global collaboration strategy. And first year, actually we have less than 6 months for first year, and maybe 4 months. So in first year, we are focusing on analyze the international standard for security, and then we're going to make or establishing international collaboration system or framework or some structure. And then in second year, we're going to focus on mainly developing product and technology for security. And then we are expanding our international collaboration with more countries. And last year, we're gonna make some sharing structure. So we are sharing our result of technology, and then we can disseminating our collaboration activity. So in figure shows that in Korean team will collaborate with 6G Forum in Korea, and also we are working with 6G flagship at the University of Oulu in Finland. And then we also looking for collaboration with VTT for demonstration, for maybe validate our technology in real network testbed environment. It looks like it's 5G TN. Actually, 5G TN is provided by VTT and University of Oulu. And last one is we are focusing on collaboration with US NIST. As you know, NIST has many important and very high level is standard in the America. So we are planning to make a collaboration for the international standard for 6G security as well as 6G resilience technology. Okay, for more detail. So actually this is the last slide. So I'd like to introduce global collaboration research topic. And the figure above shows that Korean team and, conduct international standardization and most of R&D product. US NIST will conduct research and standardization of 6G resilience technology as well as their cybersecurity framework update. And then also we're gonna working with the zero trust architecture for security. And next one is VTT. And I expect VTT will conduct a research and 6G security demonstration provided by their 5G TN testbed environment. And last one is University of Oulu. I expect the University of Oulu will conduct in privacy preserving AI, ML technology. Okay, so the figure below shows that the quant status of ITR working part 5D activity. So it shows the capability of IMT 2030 on the left, and then it shows that working part 5D timeline for IMT 2034 on the right. So actually, I'm having participating in ITR, working part 5D, since 2020 to develop 6G security standards. Unfortunately, actually, it's only October. They have one meeting. There is name is 47th meeting. But unfortunately, I attended remotely. But still, I'm monitoring and I work with their committee for the 6G technology and 6G security. Okay, that is my presentation. So I have one remark. So if you are interested in this project, please contact me and then we can discuss more and more details. Thank you, everyone.
Thank you very much, Professor Kim. I would like to invite our last speaker for this session and for the day. Or almost, yeah. But
Good afternoon, everyone. My name is Seung-myung Jung, working for KT. KT is Korea Electronics Technology Institute, and I have no knowledge about the electronics, but this is about the IoT and AI, so this should be a really friendly topic for you. And as said, so this is the last presentation, and I was not expecting my presentation to be the last one because the session title was Cybersecurity, IoT, and 5G, or 6G. So yeah, I didn't expect that. So I will kind of make it short and not so boring for you. So IoT platform. So IoT platform is the first topic because when we talk about the IoT, there are so many aspects for the IoT. IoT device, services, platform, and our main focus was IoT platform. And there is the kind of wording like the 1M2M. 1M2M is the global standard, which is the de facto standard from all the companies and the research institutes, and it has been over 10 years. So my presentation starts with the history. So this is not the future trend, and it's more likely what we have been done for the IoT area. So this is like the kind of over 10 years kind of achievement. And there is the wording like the Mobius. Mobius is the kind of standard implementation of the 1M2M for the server and the other kind of platforms. And Mobius, as a kind of 1M2M specification implementation, it has been kind of released at the open source. And as the kind of KT, which is the Research Institute, the non-profit organization, we really wanted to kind of make it public for all the research or even for the SMEs or the other businesses to use because this is the standard technology. And we also use the Mobius and the 1M2M standard for different R&D projects. And yesterday, the last session, the EU funding support, the talk or the session, there was the kind of brief introduction, how many or what kind of organizations from Republic of Korea has been engaging the Horizon projects, and we were one of them. And probably the other research center in KT could have been done for the other projects, but from my perspective, our research center, we have been done like the Fiesta IoT and the Wise IoT and the Synchronicity. And the main topic that we worked with the European partners was the interoperability. And for example, the interoperability is like the system level, like the different interfaces, like the European side, NGSI, and Korean side, or the global side, 1M2M. And that is the interoperability, like the base level. And on top, there is another topic, like the data level interoperability. And that's why you can see some semantics in the slideshow. And yesterday, Cloud Edge IoT session, there was a really brief introduction or the discussion regarding the semantic interoperability using ontologies. And from those projects and the experiences, I think semantics is really good technology, but it is another big hurdle. And I see a really good solution to make all the life easier, which is the large language models these days. Because basically what we really wanted to do with the semantics and ontology for the data interoperability is to describe the data or information as machine readable one, and they can be used by machines, and they are kind of interpreted, for example. And large language models, even we put the description in human readable ones and in English or French or even in Korean. They understand, and they can produce or they can reason, they do the reasoning by themselves. So I think that is a really good topic for the new kind of projects or the collaboration. So I'm super curious about the next call of the Horizon Europe, because we are now the associate member for the Horizon Europe. So if there is any chance or the topics that we can all leverage IoT or the other technologies again with the LLM for the data level interpretability, then we are so interested. And after the kind of ordinary or traditional IoT, which focuses on the connectivity or the other kind of common functions that we use for the IoT, we add AI. That's why we call it the AIoT. If we say, okay, I'm working for different technologies in IoT domain, then that's a really old-fashioned. So we, at least in Korea or the other countries, we use AIoT because IoT is not the only one, but based on the IoT technologies, on top we add the other technologies as a stack, like the AI. And this is one of the projects that we finished a couple of years ago. And what I want to say is in the middle, there's the kind of radii platform. The name is radii because we use the kind of radar sensors, which can see through the boxes or something, which cannot be done by the vision sensors or our cameras. Anyways, we extend the 1M specifications or our kind of implementations, which is open source, to kind of support the AI kind of services. And what we mean by the AI services on top of IoT is 1M basically collects all the sensor data and kind of share data through all the devices and the applications. And they are the basic sources to kind of train our AI models. So there was the one kind of new feature suggested or prototyped, which is the AI training model data set from the IoT sensors. And the other one is the AI model management, like the model repository and the deployment management over the different kind of sensors in the field side. So they are the new stuff that we add in, and we have been kind of proposing those new features to the 1MTM standard. Okay, I need to kind of speed up. And from this slide, there are some applications that we use IoT and the AI. And one big topic is the drone. And of course, these days, there are so many different applications that we use drone. I don't have to name it. And we use a drone controlling system on top of the IoT like this. And there are several applications. Basically, the control is the kind of ground control system, GCS. And if you can see, so we track all the locations, or we can manipulate the drone kind of operation, and we see the real-time status of multiple drones. And of course, we can get some kind of service data. And in this case, that is the LTE signal quality for that. And like over the 70 or 60% of the land in South Korea is mountain area. So there are so many kind of areas that LTE signal is really weak. So there was the application for that with drone. And we presented this one also in ETSI like 2 years ago at the ETSI IoT Week exhibition. And we use drone, and of course we use the kind of physical drone, but we also kind of made the kind of virtual drones in the simulators, and they use the same kind of protocol for the unmanned vehicles like the MapLink. And these days we even, not this one, so in this case we use the kind of on-device AIs, like the kind of robots with the 4 wheels and the drones. They have the kind of AI models kind of running on the device itself, and they detect some kind of events like the fire or some unexpected kind of people in the secured area, something like that. So that's the kind of basic stuff, and they even kind of cooperate together to aware the situations. And this is the kind of ongoing project. And so basically we have everything that I have been kind of just describing. And on top of that, there is the kind of gesture recognition and the voice recognition. Of course, that's being done by the kind of AI, like the deep learning. And we use it kind of to manipulate all the unmanned vehicles like the drones, which is the UAV, aerial vehicle, and the UGV on the ground, and USV on the kind of ocean surface area. And also, we have kind of different types of kind of ground control system, like the PC version or the field version. And the next one is the kind of XR version, which is basically the digital twin or metaverse version. So the operator just kind of wear the HMD, and they can just kind of see all the operations in that kind of glass. A bit different topic because we have been kind of working on IoT over 10 years, and IoT is device-centric, but we really see the kind of opportunities to kind of look close into the data. That's why on top of IoT, we also worked on the kind of data platform. And like the European partners, we adapted the NGS-LD standard interface for this one. And this one has been also kind of released at the open source. And there was a kind of system that we made in 2020 for the COVID-19, because there was a kind of really big number of kind of new cases every day in that time frame. And we had the kind of smart city data hub, which is the data platform that we already have as a prototype, and we used it because basically we really needed the kind of proven data platform. And on top of that, there is the service to track all the new cases, their routes, and something like that. And this is the last slide, and this is the ongoing project as well. So we extend or we adopt those kind of data platforms that we have for different domains, like the climate control or the environment monitoring or water resources. And in this case, this is regarding the kind of urban cooling technologies. And we don't kind of work on the urban cooling, but this is also kind of data and AI-driven approach. And we want to kind of extend our platform for the AI model kind of serving framework. That's it, and I think from the Dr. Ko's presentation, the very last thank you slide, there was one Hindi wording, and I cannot read Hindi, but what I learned before is thank you in Hindi is shukriya, right? Thank you.
Thank you very much. Are there any questions to the speakers?
Sara Medina from SPI Portugal. Many thanks for the great presentations. I have a question. I think can be I think for everyone. What do you see? I think it was very interesting to see projects of cooperation. So the participation already in Horizon projects, and also the cooperation with the European partners. So my question actually, it's two questions. The first one, what type of, and also of course to the two other speakers, including Rui from Portugal. So the two other questions, the question is, what do you think are the major challenges in terms of your experience of concrete project cooperation between Korea and with Europe? And the second question is, now with the new Horizon as SPI, as Korea will be associated partner, how do you see that this can benefit better the Korean organizations in your field? Thank you.
Okay, thank you for your question. May I answer some of the question? Regarding the Korea-UK collaboration platform, I had several experiences, one from very tight coupling and the other from very loose coupling. The tight coupling means that we set up the goal. We made consortium together, and we performed the project together, and we disseminate the output together. But there's very tight coupling. But recent trend is that more loosely coupled type is preferred between EU and Korea. But my experience is that some more coupling is useful or necessary. So that is my view on future trend, future direction for collaboration. And regarding your second question, from next year, Korea will be the associate country. I do not know the details of the budget submitted to EU, but I think maybe it's a very big scale. But so far, our collaboration project is a small scale compared with that. So maybe from Korean side, we need new approach to handle big size of budget. That is what we should prepare. Thank you.
So just briefly regarding the challenges and the benefits to work with the European partners. The challenges, I think, I don't remember specific challenges or difficulties when we were kind of doing the projects, but I think the major challenge for us is to set up the network to kind of propose as a kind of consortium. So of course, the European countries, they should have kind of stronger or closer networks together because geographically they are kind of sit together. But from Korea, which is Far East, it is not so easy, especially when you have some kind of willingness to kind of participate the Horizon project, but you don't have any experience with the partners before, then it's really, really difficult, I guess. And I think this should be the same situation for the newcomers, because even we have several kind of experiences, but we would like to kind of jump in again, but it's not so easy for us. And the benefits, and this is what I'm saying to my colleagues or the other people when we talk about the kind of collaboration with the European partners. I think the biggest benefit is the kind of getting the up-to-date kind of technical trends and some tools, because there are so many kind of good organizations in the Europe, and they really always look into the kind of future roadmap and the new technologies, and even for the kind of project implementation itself, they have kind of really good kind of software tools that they are already using. So that was a kind of one of the benefits, as I remember. Thank you.
Okay, thank you for the question. I think Professor Lee summarized everything when he said that you have different models of cooperation, loosely coupled, medium coupled, or highly coupled. Now, the transformation into associated partners will necessarily move to very strongly coupled. That will, for one hand, raise some problems, which, as Professor Young was saying, there is a lesson of learning and establishing those relationships. But on the other hand, will simplify a lot what is the largest problem in international cooperations, which is the synchronization of different funding measures. So in Europe, we know the rules of the game. We know when the dates come. We know how the process goes. Every time we try to synchronize, we need to have this intergovernmental agreement, and the laws in different countries are different. The timings and the budgets are allocated differently. So there is always a very hard problem, at least in the industry-oriented projects. Of course, we are talking about loosely coupled, which means some universities cooperate and we have more or less overall objective. Then it's much easier because you don't have a very strict technical annex that you need to follow with this deliverable at this date. More or less 3 months is more or less 6 months, is nobody will die for that. But on the industry-oriented projects, this is really a problem. And in fact, when we do have projects like that, typically there is a major common industry player. For instance, in Korea, Samsung will be a typical partner on that project in order to smooth these, sometimes are cultural, sometimes are timing, sometimes are procedural aspects that need to be overcome.
There is, I think, one more question.
Yeah. Quick question, and actually perhaps for any of you, maybe particularly the professor from Portugal. If I look at the 5G standards, right, and I mean, it's probably an accurate depiction to say that large portions of the 5G standard have really not been broadly implemented yet, right? If I look at, new communication modes like URLLC or MMTC or even things like network slicing, it's probably, I mean, I don't know if you would agree with this, but I would say that, it doesn't seem like there are too many use cases that take advantage or even availability of these features yet. So my question really is, why are we working on 6G at this point? I mean, what's the reason I mean, are we putting the cart before the horse? Yeah.
That's a great question. You should have been on our 5G session yesterday. Now, forget 5Gs. I've tried once to talk with a couple of manufacturers and ask them, tell me which percentage of the 3GPP specifications are in your equipment. Nobody wanted to answer that, okay? So let's say that on the standardization bodies, we are very good in producing documents, and some of them, then I will almost think that it's a sort of, the law of the fittest. Some of them survive into real life, some of them are not. For those that are in this game long enough, we keep on hearing the same type of concerns, recurrently appearing every couple of years and say, but didn't we solve that 10 years ago? Yeah, but nobody's doing this and we still need to solve it now. Okay,
so let's do it again.
Let's do it again, which actually facilitates a lot because we already know a lot about it. Now, the problem with 5G is, look, we can say that 5G had 3 clear legs, as you mentioned. One is a success. The EMBB is a success. This is very clear. And it's more or less like quality of service in the internet, right? We have much more intelligent ways of doing quality of service than what we do in the internet, in the IP network. But people are not aware of it, think that the IP network is still best effort. It's not. There are some small mechanisms in place that allow it to work very well. Probably what went with the URLC and MMIoT is something similar. The EMBB was the driver, that's what people are taking, and we are able to provide some types of services which would say low quality URLC or low quality MMIoT without having to deploy significantly change technology step. And this is where we are. We don't see the customers claiming in general for localized networks which are much cheaper. Yeah, you can have specific requirements there. For nationwide networks, we have not yet seen the customers coming and saying, we need this. And now these systems are extremely expensive, okay? And of course, the operators are not going to do the rollout until there is a customer that appears. And the customer is not asking for a service until there is an operator that says, yeah, I'm providing this service to you. So this is more or less where we are stuck. Answering your question, we are doing 6G. Because regardless of all this, and even if, from my point of view, what we are promising 6G, maybe 50% will not come true, right? There are still things, or there are already things that we know that we can improve. One very simpler thing is we cannot keep on with the power levels that we have today with the expected traffic that everybody's ongoing. Forget the complexities. Just the simple fact that the traffic that people are doing today and the way it's increased, the way we are increasingly more resorting to more complex actions, which everybody talked about AI here, but nobody discussed the cost of AI. And it's not only the computing cost, is you need to get data to a data center. This means you need to have a network. So all these kind of trends are leading to enormous increase on the communication needs. We cannot support it with 5G unless we want to start turning on, nuclear powers every day, like the guys in AI are claiming that they are going to do, right? So there are reasons for us to move from 5G to 6G. Maybe not all of those are. Maybe the reasons that are needed are not all of them that are stating.
Okay, since currently I'm participating in 3PP, so I agree with your comment that the many feature functions are not implemented or delayed the implementation. That's true. But so based on that lessons now in 3PP, inside 3PP, we are discussing to make the 6C specification more simple than before. Not allowing many options. So that is lessons from 4G and 5G.
Thank you very much. I think with that, I would like to close this session, and thanks again for the speakers for their contributions.